So 4.4 is what we call the fundamental theorem of calculus. It will be presented in two different parts. The way that you do this is presented a couple of different times. There were several examples. But if you want to boil it down to simply what it is, you find the antiderivative and you subtract. Would that be fair? You find the antiderivative, you do a strategic subtraction. So what I thought I'd do here for you guys is just start you off by working one of these with you, and then I'll have you guys try some of these on your own. So the first one, the definite integral from 2 to 4 of x cubed minus 2x squared plus 5. So as I work through this one, the first thing I'm going to do is find my antiderivative. So my antiderivative would be 1/4 x to the 4th minus 2/3 x to the 3rd plus 5x. So that's my antiderivative of that integrand.
Why not a plus C?
Great question. There technically is a plus C, and maybe just to answer your question, I'll put it in there. So what I'm going to then do is I'm going to evaluate this from 2 to 4. So you guys remember maybe from the video that vertical line from 2 to 4 means evaluated from 2 to 4. So what I'm going to do then is I'm going to plug in the 4, and then I'll plug in the 2, and I'll subtract. So this would be 1/4 times 4 to the 4th minus 2/3 times 4 cubed plus 5 times 4 plus c minus, parentheses, 1/4 times 2 to the 4th minus 2/3 times 2 cubed plus 5 times 2 plus c. Make sense? So to answer Marguerite's question at this point, can you see what's going to happen with the c's? They're going to subtract out, right? And so with a definite integral, we typically will skip that step and just say, hey, we know that the c's are going to add out anyways, and so we're just not going to write them. But I think your question is a very good one. That's actually what happens to them. They're subtracted out. So from here on out, it's basically just some arithmetic, right? Can we do all of our fractions and our multiplyings and addings and subtractings? We shall see. So this really is 4 cubed. So that's 64 minus 128 thirds plus 20 minus, parentheses, that's 16/4, so that's just 4, minus 16 thirds plus 10. So, gosh, what do we have here? 84 minus 14. So we've got 70. And then it's minus 128 thirds plus 16 thirds. So is that right? Yeah, so it'd be 70 minus 112 thirds. Did I mess up my arithmetic somewhere? So it'd be 210. So I'm coming up with 98 thirds. 98 thirds? Okay. Anyways, I'd say some of the arithmetic on that one is maybe a little excessive. Whatever. Big
We
idea.
have to do that in our head. I don't know.
Yes.
Like, would you
So,
like,
are
would
you
be
talking about
simpler, like on a non-calculator part?
Are you talking about tomorrow's quiz? 'Cause
In
this
general.
is not on tomorrow's quiz.
Yeah,
at all.
in general, like. would you
I don't know, like,
Could you make the numbers like a little more pretty? If we nail it in our head.
there's a cat that I don't want to totally let out of the bag yet about something. So let me just say, for the most part, don't stress about your question yet. I mean, if you can find it in your heart to trust me a little bit, that I'm not out to get you. There will be a cat that I let out of the bag a little bit later that she'll be like, whoa, okay. So, and it's a good cat.
Okay.
So, I can't believe those words just came out of my mouth. Because I really don't believe in a good cat. I don't believe that that exists, but that's just me personally. I'm just not a cat person. Whatever. It's not my favorite.
Anna hates my cat.
They are cute until you're petting it and you're purring, and the next thing you know, your arm is just like shredded. Maybe I do. Maybe you're right. Maybe you're right.
Say hi to them. They don't actually love you. You're allergic to them. You have to give them
Preach
They
it.
don't prey on you. Like,
Preach.
pounce on you when you come to your house. They're like hide and then they do.
All right. Let's get back to a much more pleasant topic, calculus, instead of cats. No? All right. So I want to help you guys a little bit. And I think that this advice will always be timely. For number 5, do you guys all recognize that we really don't want to have a fraction in there? We want to like flip up. But can I also show you like an error that is just like way too common? See if you can identify with this. Maybe you have done this yourself. I've seen plenty of folks think the exact same way. They're like, hey, we need to deal with this fraction thing. And they write this.
It's the negative.
You're doing two things at once, aren't you? You're making the radical a 1/2 exponent, and you're moving up. And I think it's easy when you do two things at the same time to forget one of those two things. You guys saw it right away. It's supposed to be negative 1/2. You're right. So just be careful with that sort of thing. Now that we have this transformed to a more usable form, if you guys would, see if you can do FTC 1, Fundamental Thermocalculus 1, and evaluate this definite integral. Okay? So ready to go. We'll check your answer in a minute. So when you do your power rule, you add 1 to the old exponent. And so, of course, negative 1/2 plus 1 is positive 1/2. And then you divide by the new exponent. So, of course, if you're dividing by a fraction, you copy dot flop and you end up multiplying. So this ends up being 10x to the 1/2. So that's your antiderivative. Can I point something out? And I hope that you're all paying really close attention. At this point, I've done the antiderivative, right? At this point, I've done the antiderivative. Do you see how it would be wrong for me to write this?
Yeah,
Why is that so bad?
because then that's saying that you should do it again.
I need to do the antiderivative still, right? And the truth is I already did do it. So this is telling, like I'm basically communicating that I still need to do something that I don't need to do. Okay? So instead of writing something like that, what I would do is I would put my vertical line over here and say evaluated from 1 to 9. Please keep in mind that with subtraction, the order should always matter. And so whether I plug in the 9 and the 1 and then subtract in that order, or plug in the 1 and then the 9 and then subtract, like the order is going to matter. What we do is we always plug in the number that is vertically higher. So in this case, that's the 9.
Like numerically or just like on?
The one that's like on the top.
Okay.
So, and as we'll typically do,
Could there be one that was like 0, 1?
so like we typically accumulate from left to right, but if like the bottom number was 1 and the top number was 0, you got to plug in the 0 first and then the 1 and then subtract. So you always plug in like the top one, the vertically higher.
Yeah.
That would be your pattern. So it'd be 10 times 9 to the 1/2 minus 10 times 1 to the 1/2. As you evaluate this, you see that it's 30 minus 10, which is 20. Let me retry on that. 0. There we go. So 20. What do you guys think? It's not so bad, is it? I hope you don't think it's too bad. Number 6, then, if you haven't already started on that one, please do. Number 6, before you do any kind of antiderivative stuff, you're definitely going to want to flip up those denominators. And so for number 6, you're going to want to write the integral from 1 to 2, and then it would be x to the negative 2 minus x to the negative 3 dx. So please take a minute, see what you can do with that one, so you can get to an answer. Ready, go. So with number 6, my antiderivative, I believe, would be negative x to the negative 1 minus x to the negative 2 over negative 2. Does that look about right? And then, of course, a negative times a negative does turn out to be plus positive. So I agree with that. Evaluated from 1 to 2. So I plug in the 2, and this ends up being, are you guys okay if I just write this as negative 1/2? And then I plug in the 2 into the other part. So it looks like this becomes plus 1/8. Yeah?
Yeah.
Okay. Minus, now I just need to plug in the 1. So this would be negative 1 plus 1/2. So let's see here. What would be the easiest way to do this? I guess this would be negative 1/2 plus 1/8 minus, this just becomes negative 1/2, doesn't it? And so this becomes plus a positive. So this cancels with this, and I got positive 1/8. Yeah, we good? Any questions or anything? Some of those little details, isn't it amazing? Like, you do this antiderivative and you do the fundamental thermic calculus part 1,
You don't know how to do
and the thing that you stub your toe on is adding fractions. Like, it's so frustrating. I get it. It's got to be careful. Okay, cool. If you haven't already looked at the one with trig stuff, number 7, please do check that one out. It's kind of a nice review for quiz material tomorrow. Do you know the antiderivative of negative cosecant cotangent? If you do, that's great. If you don't, might be something you want to review. Okay, so antiderivative of negative cosecant x cotangent of x is what? Cosecant of x, right? So again, like I mentioned, if you looked at that and you just thought, Lord help me, I have no idea what this is, it'd be your cue to be like, wow, I better go back and review some stuff in 4.1. So the antiderivative is cosecant of x, evaluated now from pi over 4 to 3 pi over 4. So we plug in the 3 pi over 4 first, and then we subtract the evaluation at pi over 4. And this is where your unit circle comes into play. So if I could just let you in on how I do this, I just think of cosecant as the reciprocal of sine, and I ask myself, what is the sine of 3 pi over 4? And isn't it 1 over root 2? So I'm just going to do the reciprocal of that. So the reciprocal of 1 over root 2 is root 2. Minus, well, cosecant of pi over 4, that's just sine of pi over 4, flipped. So sine of pi over 4, that's 1 over root 2, flipped is root 2. So it looks like we're coming up with a big fat 0.
Is that because, does that function look like, well, does it just have the same above the line as it does below the line?
Yes, I was about to ask that question. There must be some area above the x-axis, there must be some area below the
So
x-axis.
that's like a full period? Or
Probably half a, it's either a full or a half, I would say. And this is, I don't know, it's either full or half. But the bottom line is it contains some area above and some area below. And those two areas are the same, but the area above will accumulate as a positive, the area below will accumulate as negatives, and they cancel each other out to be 0. Yep, exactly right.
The only other time that would happen would be if like, so the line was just like 0, like if the line was just like.
Yeah, if the it would have to be a line, and it would be right on the x-axis. Yep. Great. How are we doing? Okay, so the next one has a really nice opportunity to connect back to the 4.3 material. And so let's check this one out. Hopefully this will be helpful for you thinking about your quiz tomorrow. So this says g of x is equal to, oh, we're going to do something awesome right here. G of x is equal to this piecewise function. And then it says evaluate the integral from 0 to 2.
Wait, sorry.
So I want to help you set this up. So this is piecewise, right? And so since it's piecewise, the the integrands, when you get to the division and the piecewise, the integrands have to switch. And so do you guys remember and we just talked about this a few minutes ago, do you guys remember the property if we have the integral from a to b of f of x plus the integral, right, from b to c of f of x, that's equal to the integral from a to c of f of x?
Yeah.
So we're going to go from 0 to 1/2, and then the next one will be 1/2 to 2. But I do have an additional awesome thing which I just popped out to me here. So what we'd do is we'd say that the integral from 0 to 2 of g of x is equivalent to the integral from 0 to 1/2 plus the integral from 1/2 to 2, like so.
Would you have to write that out to get credit, or could you just start doing it?
Well, I think you wouldn't really have to. You probably could just write this, the integral from 0 to 1/2, and that would be of the sine function plus the integral from 1/2 to 2 of the linear function, something like that. So I want to show you guys something super awesome that if the calculator is active, you'll want to start doing. So get your calculators out. So the reason why I'm going to show you this now is you guys have not learned yet how to deal with this if your integrand is composite. Just haven't learned how to deal with that yet. You will soon. We just haven't learned how to deal with this yet. And so I want to show you something super cool. So this is a little bit earlier than I expected, but I forgot this one was in here. So here we go. On your calculator.
Is this the cat?
No, I've got a different cat. I know, more than you thought. Okay. So do this, if you would. Just get to just a blank screen here. And what we're going to do is we're going to take that expression that we have up there. And you guys remember, I'm sure you do, you guys remember about Math 8? Remember how awesome Math 8 is? Math 9, similarly awesome. So check this out. If you push Math 9, look what shows up. Pretty cool. So all I really have to do is fill in the blanks with what I need. So I'm just going to say I want the integral from 0 to 1/2, 0.5, of sine of pi x dx plus Math 9, and just fill in the other one. So it'd be 0.5 to 2 of negative 4x plus 6 dx. There is a way for you to do this.
Yeah, I know I don't have mine today, but is there, can I come, like, you said isn't there a way to, like, download it on?
Yeah, just from TI's website. You need the special wire cable to do it, but yeah, you can do it.
Do you have that one?
Huh?
I'm gonna come in during one of my meetings.
So you hit enter and it should kick out the. You guys in radian mode? If you're not in radian mode, it'll give you something different. Is that it? Were you in degrees? Eden, was that the issue?
Yeah.
Okay. So, guys, I am making a video of this, so if you forget this later, this will just be in the folder of what to do. Maybe part of a lunch. Tomorrow my lunch is tight. unless we'll see what happens in Columbia. Maybe a lunch. Yeah. Okay, so what do you guys think? Good? All right. Let me just maybe lay a little bit of groundwork for what we're going to be looking at after the break. Let me just see here. What do I want to do with this? This will be a good place for us to finish here. Let me just ask you these questions. How do you find an average? Do you guys remember just the basic process for finding an average of anything? Add them all up, divide by the number of numbers. Exactly. So then, do you guys remember what a definite? Let me be specific here. Do you guys remember what a definite integral really is? Okay, it's an area, but you're adding up a bunch of really skinny rectangles, right? So I would say that a definite integral is an infinite summation. It adds up a bunch of really skinny rectangular areas. How do you find average? As you mentioned, add up, then divide. So what we're going to be doing is we're going to be finding the average value of a function. So this seems a little outlandish, I guess. If I've got some curve that starts here and goes up and down and comes over here, if I were to ask you, well, like, what's the average y value? And you took the old method of like, hey, let's add up a bunch of y's and then divide by the number of y's. Couldn't somebody say, well, you didn't add up all the y's really, did you?
Because
There's an infinite number of y values between a and b. So you really can't do that. So you use an infinite summation. So we would say the integral from a to b of f of x, this would literally add up all of the y values from a to b, but then we've got to divide. And so what we do is we divide by the width of the interval. We divide by b minus a. That's the division portion of finding the average value of a function. And that's going to be the formula that we move on from to find the average value. We'll talk a lot about average. We'll continue to talk a lot about average as we move forward. So I think that's our time, right? We're done at 20, am I correct? Yeah, okay. Yes, ma'am.
So if you're finding all the y values,
Yep.
because you're getting average?
So you're finding the average height, right? And so b minus a would just be simply the distance from here to here. So you're dividing by the interval from which you got all those,
Yeah.
is really what it comes down to. Because you can't divide by the number of them because there's an infinite number of them. Therefore, you'd get a zero average every time. So the way that you get the average value is to divide by the width of the interval. Because essentially what you're doing is you're adding up all the y values and saying, all right, well, these y values are spread out over how far? B minus a far.